Hey guys, so today we're going to run through investigation 3, which is the why is the water hard? Or how hard is the water? One of those. So we've got our setup here. I'm going to run through first the practice with instrumentation part. So as you can see, we've got our setup. We're ready for filtration. Unfortunately, we can't do the vacuum filtration here. Our system just isn't able to handle that. So we will do gravimetric filtration instead. And we're ready to make our solution. We have calcium chloride and sodium carbonate, 2 small beakers, some DI water, and our stir rod if we need it. Okay. As always with every lab, we want to make sure that we are wearing proper laboratory safety equipment. So we've got goggles, long sleeves, things like that. So the first thing we are asked to do is to mass out approximately 2 grams of calcium carbonate into a clean dry beaker. We do not, however, put the beaker onto the balance. That's really, really bad technique. So we're going to get some weigh boat and put that in there. So we have our weigh boat. We will put it on our balance and zero out. We'll take our sodium carbonate and weigh out approximately 2 grams, always using a scapula or something of that nature. Okay. So we have 2.08 grams has been measured out. Okay. And we're going to put that into our first beaker. It's very important that you keep all of your chemicals labeled while in the laboratory. So on the beaker, since we just put this in there, we are going to put our sodium carbonate, so Na2CO3, so that we know that this is our sodium carbonate solution. You will then go ahead and get a new weigh boat. Always get a clean weigh boat, don't ever reuse. Zero that out. And we will now obtain 2 grams of calcium chloride. And I am at 2.00 grams. Okay, so again, 2.00 grams. We're going to get our other clean beaker and go ahead and carefully add that in. Make sure to get it all as best you can. And we will label this one calcium chloride, so CaCl2. We're labeled, we now know which is in which thing. Okay, move on to the next step. We're going to add 20 milliliters of water to each beaker. So grab our DI water. This is actually really kind of the slow way to do it. So I'm going to grab just real quick a beaker with some DI water so we can pour in and then add with this water bottle. Okay, so we have our DI water. Okay, so we're going to pour in. Again, always make sure that your eyes are level with the mark that you're trying to read. So you're going to pour close with your beaker, and then you'll add in with the squirt bottle. And our meniscus is right at 20.0 milliliters. Put that into the sodium carbonate. We'll do this again. Get your rough measurement with your direct pour. Get close. And then finish it off with your squirt bottle, but again, this has to be eye level so that you can read your volume properly. So again, 20.0 milliliters. Okay, so we're going to mix both of these carefully. Okay. You can use the stir rod if you want to. But oftentimes just a nice swirl is going to give you a much quicker and better mixture. If you did have stir plates, magnetic stir plates, you could plop one of the magnetic stir bars in here, put it on a stir plate and let it do its own thing. Free up some time. Almost there. Again, you got to get this thoroughly mixed, okay? Thoroughly mixed. If we recall from our solubility rules, all sodium substances are going to be soluble because it's an alkali metal. Alkali metals are always soluble. Okay, so we get this nice and mixed. There's some bubbles on the top, but there's no more solid. And we'll do the same with our calcium chloride. And if we recall, chlorides are also always soluble. So we do expect this to go fully into solution. A little bit more. So there we go, a nice clear solution. Okay, the directions then ask you to take a little bit of your sodium carbonate and pour it into the calcium chloride, just a small amount. Okay. So two mildly cloudy, colorless solutions. And we immediately get a white precipitate when we put in the sodium carbonate. Okay, so we're going to keep adding small amounts and stirring thoroughly in between. We've gotten all of the sodium carbonate is now into the other beaker. We'll give it another nice stir. We've got a nice white, opaque solution here. Okay, you can see. Okay. So now we're going to get ready to filter. First thing we're going to do is weigh our filter paper. So we'll zero out the balance. Our filter paper records a mass of 0.94 grams. Okay. And to set this up for filtration, we're going to fold our filter paper in half and then in half again. Okay. And open up the very first flap. Okay, so just the very first flap so that we actually have a solid base. Okay. Put that into our funnel and gently wet it. We want the filter paper to stick really well to the funnel so that none of our filtrate goes down the sides of the funnel. That would be not good for us. All right, so we're going to go ahead and do our gravimetric filtration. You're going to pour a small amount. I always recommend get a nice swirl going so the solids get carried with the solvent. Okay. Pour in. Do not pour past the filter paper line. So again, we're not pouring up higher than the filter paper, even though the filter does go higher. Doing that, you get a high risk of having that the filtrate actually go through the side. Okay. So I'm going to move this a little closer. And we wait. As enough of the substance that gets filtered through, we'll go ahead and add a little more. Again, being very careful not to fill over the edge of the filter paper. So as I mentioned, this is very much so a waiting game. One way to help it along just a smidge, I lower this a little bit. If you put the bottom of the, especially the side that it's actually coming through on, of the funnel up against the glass that you're filtering into, it'll oftentimes use the adhesion of water due to hydrogen bonding to pull the water through just a little bit more fast. It's not significant, but it can be at times. Even though this is empty, we're not done yet because there is plenty stuck to the sides. So the best technique is to leave this tilted upside down and just rinse down the sides. Having it be upside down is going to actually allow gravity to help pull any of the solids out of the beaker for you versus you having to keep swirling and swirling and swirling. Okay, it's just a helpful thing. This particular one does not squirt very well. I'm going to go get a new one. Luckily, while you're filtering, nothing's really a rush. Again, be careful as you're rinsing to get as much of the solid as you absolutely can out. Okay, since we're having the water go through the filter paper, it's okay to use excess water. But do be sure, again, not to have your water level, your solution level, be above the filter paper. So when you look like you got all of it out, okay, I don't really see anything in there any longer. So now we're just going to let it finish filtering. We're going to let it go all the way down. We're going to let it filter completely. Okay. Point, we can see there's no visible standing water. Okay. So this is how we're going to know that our gravimetric filtration is done at this point. And we're going to go ahead and move on to the next step. So we have our watch glass here. You're always going to want to label your watch glass because when you put it in the oven with several others, you need to know which sample is yours. So I have my initials on my watch glass. Okay. We are going to very gently peel the filter paper from the funnel, and we're going to open it up, being very careful not to get any of the solid on our hands or any other transfer whatsoever. So we spread it out on our watch plate, and we're going to go put this in the oven. Okay, sorry, so I'm going to put that for 1 second. And we have it heated, okay, to approximately 100 degrees. There is a thermometer up there. Okay, and we put this on in. And we're going to leave this in here for a while. The idea is it's going to expedite our drying process so that we can finish this lab a little sooner rather than later. In the meantime, we're going to clean up. I've already got in the sink, I've got a couple of beakers with some Alkanox. We're going to go ahead and get the rest of our glassware and make sure that we clean everything and put it away where we found it prior to leaving the laboratory. Okay, so here we go. We come on in here, we can see that there's no more liquid whatsoever. It's quite dry and brittle. Okay. The glass itself is going to be really hot, so we're going to want to make sure that we are prepared for that. And I'm going to wear an oven mitt to do this, okay? So we're going to go ahead and take this out of here. On a wire gauze so that it doesn't crack on the cool desk. Or enough, we want it to cool, not dry. So once this is back down to room temperature, we're going to go ahead and get the mass again so that we now know how much product we've collected. Okay, so once this is fully cool, We're just very gently going to go ahead and put this onto a zeroed balance. The same balance that we used last time is really important. And we get 2.32 grams.